This video should clear up some questions that you may have about frequency labeling. Here we're concerned with how the delay time affects the strength of the signal. Let's look at an example in which the signal is killed. Remember that in the COSY spectrum we have two 90-degree pulses, a first and then a second 90-degree pulse. Let's look at the magnetization right after the first 90-degree pulse. After the first 90-degree pulse we have this magnetization precessing in the XY plane. If the delay time is such that the magnetization is right on the x-axis, then all of the magnetization gets transferred to the negative z direction, and then T1 effects take over, and the magnetization returns to the positive z direction. Let's have a look at what happens when the second 90-degree pulse is timed just a little bit differently. Here we have a different delay between the first 90-degree pulse and the second 90-degree pulse. Now the magnetization is at 90 degrees from the x-axis, and none of it gets transferred to the negative z direction, or the z direction at all, and it just keeps precessing in the xy plane. Of course, T1 effects are going to take this precessing vector back to the positive z-axis after a while. Let's look at an intermediate situation in which the magnetization is partially between 0 and 90 degrees. Now the overall magnitude of the vector is split between the y-axis and the negative z-axis by the second 90-degree pulse. There is a projection on the y-axis from the mz vector that is precessing in the xy plane. And that shadow is the only amount of magnetization that's going to end up on the y-axis that is going to produce a signal. So we have to shorten that y vector by a little bit. But we can't just create magnetization out of nowhere. If that vector shortens, the negative z magnetization also has to shorten. And now we have these two vectors, one pointing in the negative z direction and the other pointing in the y direction immediately after that second 90-degree pulse. And now the z magnetization is going to continue to precess in the xy plane, and under T1 effects is going to eventually return to the positive z direction. The magnetization, or the portion of the magnetization that is in the negative z direction, is also, under T1 effects, going to return to the positive z direction. But this situation is going to result in an intermediate signal because the portion of the magnetization that is important to the signal is that precessing magnetization in the xy plane.